Hi, and welcome to Phase 2 of the Self-Driving Car course, A Virtual World. This is actually a standalone, so you don't need to have watched Phase 1 to follow along. We'll start building this world from scratch, using some basic HTML, CSS, and a lot of JavaScript. And whether you'll fill it with self-driving cars or something else is completely up to you. The focus will be on generating the world itself, and I'll only integrate the self-driving car code at the end. I made this course to prepare for Phase 3, Understanding AI, where we'll focus on neural networks and other AI techniques. I hope that by the end of Phase 3, you'll understand why neural networks work, why hidden layers are needed, and things like that. But for that, we need this fancy world to generate complex scenarios. The one we had earlier is too simple to teach you all that. So if neural networks is what you're waiting for, be patient and enjoy Phase 2 meanwhile. You'll learn a lot of things in this one as well. A set of skills I really benefited from during my PhD and my time at Microsoft, and I'm sure they'll be useful to you as well in your career. We first learn about graphs, and I'll show you how to implement a spatial graph from scratch. I'll also show you how to make an editor for it as well. It will have a dynamic viewport so we can pan and zoom to edit graphs of virtually any size. When building this editor, I'll explain the mathematics and logic behind good user interfaces in modern pieces of software, and we implement something similar ourselves. Then we use geometry to generate the road borders around the graph. I'll teach you about polygons and some useful operations using them. We'll apply the same techniques in a slightly different way to generate the buildings and the trees as well. We spent 2 lessons on these because I want to show you how to implement this 3D look as well. They're not really 3D models, just a little bit of math that gives that illusion. Then we implement a way to add markings to the road. This will make Phase 3 even more interesting because we'll need to teach the car to respect all kinds of traffic rules as well. Now, we'll focus on making this world editor a pleasure to use, minimizing the number of clicks and maximizing the amount of auto-generated content. But I'll also make videos on how to load real-world data from OpenStreetMap so the car can drive in your city as well. This is Joensuu. The car just passed by Karelia University of Applied Sciences. That's the Wärtsilä campus where I'm currently filming, and it started off at Tikkarinne, the other campus. And now it's heading towards city center where I've marked some IT companies on the map. Looks like the car is heading towards Arbonaut, which is on the other side of town. I'll add a link to this demo in the description. Check it out. It's a good way to learn about Joensuu if you plan to come study with us. You'll find many useful links there as well. Oh, and I'll also make a video for creating this minimap. It really helps when the world is big, and the minimap was probably the most requested feature I got in Phase 1. I've tried answering to all requests when making this, but there's still a few I'm leaving for Phase 3. They fit better there. Now, to be clear, this project is complex, especially because we're going to code everything ourselves and not use libraries. It won't be easy to wrap our minds around it all. But I divided it into components. Lessons that I believe are easy to understand on their own. I consider this course to be at an intermediate level, but I do encourage beginners to give it a shot as well to get an idea of what a more complex project looks like. I explain everything the best I can, and if you have difficulties, just ask in the comments or on my Discord. The prerequisites are high school math, and if you have trouble with that, this playlist will have you covered. You'll also need to know some JavaScript. If you completed Phase 1, you'll have no problems here. But if you need to brush up on it, I explain some tricky JavaScript syntax in these sketches, so check them out if needed. I hope you're excited, and thanks for being patient this long. Can't believe it took me over a year to make this, but I wanted to do it justice since you liked Phase 1 so much. And by the way, many of you wish to thank me somehow, so I've set up channel memberships, and you can also buy me a coffee now. Channel members will get videos earlier than everyone else. Like, Lesson 2 is already out now when I'm posting this. I'll also add some extra content from time to time, and I'll prioritize your comments. Starting to be quite many of them nowadays, and I'm not sure how long I can still reply to everything. Now get your editors ready and let's code something out of this world. Get it? Because we're gonna make a virtual world. No, no, no. Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now. I'm gonna code everything using Visual Studio Code, and we'll begin somewhere in an empty folder on your computer. And let's create our first file here. It's gonna be index.html. And we begin with basic HTML. We write the doc type here and the HTML page structure. In the head, I'm going to add a title, and the title of this will be the world editor. This will make it appear in the browser tab, and let's make it also visible by typing it inside of the body in an h1 tag, like this. Now, most of our functionality is going to be built on top of an HTML canvas element. So let's add a canvas element with ID myCanvas onto the page as well. Now let's open this in our browser. I'm going to be using Google Chrome, and remember to open the developer tools as well. It's really important to know if you make any mistakes, the errors will pop up here. Now you can see here the title of the page is correct and the h1 tag is here, but the canvas is not really visible. It is there. If you press this button right here, you can find it on the page, but it's transparent and we can't see it. So let's add some styles to this page. I'm gonna go here below the title and link a CSS file like this called styles CSS. We're gonna create this file here, styles CSS, and for the body, I'm going to give it a black background color. And I'm going to align everything to center like this. The H1, I'm going to give it a white color so that we can read it on the black background, and set its font to Arial. I think it looks better. And finally, the canvas, I'm going to give it a background color that we can see on this black background. And I'm just going to use this shade of green that I like. Let's save this and refresh, and it now looks like this. I'm going to make the canvas bigger, and we're going to use JavaScript for that. In index.html, we'll write JavaScript code here at the end of the body. We begin with the script tag, and I'm going to set my canvas width to 600 and my canvas height also to 600, because it fits my screen well pretty much, but you can choose other values if you want. Now we're going to be drawing on this canvas, and for that we're going to need to access the 2D drawing context of this canvas like so. And we will draw a graph. Let's pretend that we have a way to define a graph like so, and that the graph has a way to draw itself on a given context. So we're going to need to implement these functionalities, the graph itself and the draw method. And we'll do that in a separate JavaScript file. I'm going to include it here. We're going to place JavaScript files in a folder called JS, but this is going to be a pretty big project, so we need to think about code structure early on.
And I'm going to place the graph itself in a subfolder called math and then graph.js, like so. So let's create the JS folder first. And inside of this JS folder, we're going to create math, another folder. And inside of math, we create our JavaScript file, graph.js.
Graphs are data structures made from a set of nodes, also called vertices, and a set of edges, or links, that represent relationships between the nodes. Like in a social network, a graph can store which users are friends. These relationships are bidirectional here, but in other applications, like here on YouTube, I may be subscribed to you, but you may not be subscribed to me. There is very much to say about graphs, like we already used graphs in phase 1 when implementing the neural network. There, the links had weights, so we were dealing with a weighted graph, and there was a link between every input and every output, so we used a matrix to represent those relationships in memory. But now we're going to implement a new type of graph, called a geometric or spatial graph, where nodes are not just abstract things. They will represent road intersections, or places where the road geometry changes like this. You can see there are not so many links here really, so a matrix would be mostly empty and not the right choice in this case. When implementing a spatial graph, the proper way would be to separate the node metadata, the points, from the connections themselves. But I think it makes things too complicated, and since this whole project revolves around geometry, I will simply say these are the points and they will be connected by segments, with one point at each end. So a bit unconventional here, but I think it simplifies things in our case. Now let's code one of these graphs in JavaScript.
It's going to be a simple class, and its constructor is going to have two parameters. We built the graph using points and segments. I initialize them to empty arrays so that you can create an empty graph as well. Now let's store these parameters as attributes like so, and implement our draw method that takes the canvas context as a parameter. And I'm just going to loop through all of the segments that we have and tell each of those segments to draw themselves on the canvas context. We don't have these segment objects yet, but they will be there and they will have the same kind of structure as the graph has. It's important to be consistent with these things. And then I'm going to do the same thing for the points, like so. And I draw the points after the segments because I don't want the segment lines to be on top of the points. It doesn't look good. Now let's implement these segment and point objects. In index.html, I'm going to copy this line and I'm going to place these in a folder called primitives. Points and segments are primitive objects. So let's write here primitives point and primitives segment like this. And inside of this JavaScript folder, the main one here, not inside of math, I'm going to create a new folder called primitives. So it's next to the math folder here. And in it, we create a new file, point.js. It's also going to be a very simple class. Constructor takes in x and y as parameters where we want the point to be. And we set these parameter values as class attributes like so that the object knows where it is, pretty much. And then in the draw method, on the given context, I'm also going to pass 2 more parameters to style these points a little bit. The first one is going to be a size, maybe 18 pixels, and a color. I'm just going to use black. We're going to draw the points as circles, and the circles need a radius. I'm going to just calculate that as half of whatever this size is. And we begin a path. Set the fill style to this color that we have in the parameter list, and use the arc method of the drawing context. And draw this at this x and this y. We pass the radius next. And the last 2 parameters specify that we want a full circle. So starting at 0 degrees and ending at 360 degrees. But we have to write this using radians. That's just how the function works. So 360 degrees is 2 pi radians. Now we fill. And we're done with this point for now. Let's do the same thing with the segment. So create a new file called segment.js. Our segment class, the constructor will have points this time, p1 and p2. Let's save these as attributes of the class and implement our draw method. Given a context, and again, I'm going to pass 2 parameters here as well. The width, the line width, how thick we want the segment to be. I'm just going to give it a default value of 2. And a color, again, I will set it to black, like so. And we begin a path. We set the line width to the given width, and we set the stroke style this time to the given color. We move to the first point, p1x, p1y, and now we're going to copy this line and line to p2x, p2y. And then we stroke. And we're done with these core functionalities. The only thing left to do is test. So make sure all your files are saved. Go back to index.html and let's pass some actual points to this graph. I'm going to go here above where we define the graph and say P1 is a new point at 200 pixels. Let's copy this a few more times and have here P2, P3, and P4. Maybe P2 is going to be at 500, 200, then 400, 400, and 100, 300. And let's pass these as an array to our graph here as well. This will be the points parameter of the graph, and the segments will be the second parameter, but we can actually test now already. So save the file, refresh the page, and there's our graph. It has the 4 different points. This is the 200, 200. This is the 500, 200. Keep in mind that 0, 0 is this top left corner. So 500, 200, like so. Let's add segments as well. I'm going to go here and say S1 is a new segment between P1 and P2. And let's copy this 2 more times, maybe S2 and S3. Between, let's just link P1 for now, P1 with P3 and P1 with P4, and pass these as the second attribute here. Save and refresh. And we can see now the segments as well. Let's connect these two as well. So I'm going to copy this as S4 between P2 and P3 and passing S4 here, like so. Good. Now, this is a static structure. We can't really edit it in any way. And the next thing we'll do is add some functionality to add points, remove points, add segments, remove segments, and so on. We'll do that in a very basic way by adding here buttons that just add some of those elements on the screen. I want to teach it like this because it's how interfaces were made 30 years ago. And then we're going to make it modern. I want you to see how things have changed since then. So let's go up here, and below our canvas element, I'm going to define a div with an ID of controls, and this is going to contain some buttons that we can press to do operations with our graph. The first button, on click, it will call a function called add random point. Let's call this button add point like this, give it the label, and let's implement this add random point function next. I'm going to just make it here on top of this script. These functions will go away at some point. We just need them to develop the core functionality. So I'm not going to worry about the code structure too much. And add random point, it's going to tell the graph to add a point. The graph object will have this functionality. So let's pass here as the point a new point and give it random coordinates. So the x is going to be random, and I'm going to scale this by the width of the canvas so that the value is not between 0 and 1, what this gives, but between 0 and 600 pixels. And the height in the same way. Now, to see this point after it was added, we have to refresh the canvas. We do that by clearing the whole canvas, starting at 0, 0, top left corner, and width, height, bottom right corner, and then we tell the graph to draw itself again. So graph, draw on the context. So let's implement this add point function real quick. We are going to go to graph.js. And here below the constructor, we say add point, a given point, and we just take the points attribute of the class and push the given point, like so. Now let's refresh, and when we press this button, you can see a new point was added there. You can try pressing it multiple times, and it's going to work pretty much always, unless we run out of memory, but that's not going to happen anytime soon. Now, there is one situation that I want to take care of. I don't want to have 2 points at the same location. It makes no sense. Points are identified by x and y, and if you have 2 of them with the same x and y, then that's the same point. So let's see how we do that. We're going to need a function that checks if the graph already contains a point, right? And I'm going to write it like so, using the array find method, which finds inside of these points a point that equals the given point, like so. What happens here is that the find loops through all of the points here, let's call them P, and then returns the one that equals point. And if it doesn't find that point, then it's going to return nothing. So something and nothing will also correspond to true and false in Boolean logic. And we're going to use this as such. It's just how JavaScript works. So equals here we need to implement as a method to the point class. We need to check if p is equal to the point somehow. So inside of the point class, I'm going to implement equals point and return if this x is equal to point x and this y is equal to point y, like so. This will only be true if point and this are the same. And now we could go here and check to see if the graph contains the point before adding it. Or we could add a new method to the graph that tries to add a point. And then maybe we monitor here the success. Did it succeed to add a point or not? Let's log this in the console right here. So we can go inside of graph.js here and try add point is going to check if this point is not part of the graph at the moment, then we add the point. And notice here how I'm reusing the method we defined earlier. Then we also return true. It was a success. Otherwise, we return false like this. Let's save, refresh, and when we press this add point, same thing as before happens pretty much, but we always get here this true. That's because it's really unlikely to randomly generate another point on top of an existing one. But to test, we should force that to happen somehow. So I'm going to go here in index.html, copy this entire function here, paste it here in the console, and instead of having random, I'm going to write 0.5 and 0.5. This means that I'm going to overwrite this function so that it generates the points always in the middle of the screen. So if we press multiple times on that button, the same point will come again and again. To overwrite, we have to press enter now. And let's press this point again once. And this is the point in the middle of the screen. And when we try adding another one, we get our false as well. So it wasn't a success. And the number of points in our graph points, 18, doesn't change. Now we have a way to add points to our graph. Let's add segments as well. We're going to go here and copy this button and call the other one add segment. And the function will be add random segment. And we define that function here. Add random segment. This will work a little bit differently. It first gets the points that we want to connect and then creates the segment. Let's get these points again at random by using floor of random times the number of points. Floor makes sure that we have an integer value. And let's copy this for another index, 2 different points. And then tell the graph to add a segment, a new segment between the points at index 1 and points at index 2 like this. Now, to see any changes after we press this button, we also need this thing right here, clearing and redrawing the graph. So let's save this and go to GraphJS to implement this add segment method. We go here, below the points section, and let's implement add segment. Let's call it seg, and it's going to take the segments of the graph and push this new one at the end. Let's save this, refresh, and now when we press add segment, it added a segment here, and now I pressed again and nothing happened. Let's try again. Nothing. Nothing, nothing. What's wrong? Can you figure out what the problem is? Pause the video now and try to figure out the answer for yourself. Or just listen to me carry on. The issue is that here, where we are adding these segments, sometimes index 1 and index 2 could be the same. So we create a segment from one point to itself. We could check here and say success is false. And then if index 1 is different than index 2, success is true. Let's also add the segment only in that case, because a segment from one point and to itself doesn't really make sense. And let's log this success here as well. Refresh, and when we press add segment, we get the true and we see the segment when it appears, but sometimes we get the false when we try to link the same point to itself. And if we press more times, oh, we got the true now, but I didn't see any change. What happened? Try to figure out what happened. Pause the video, and now I'm gonna tell you the answer. So, turns out it's possible that you add the same segment multiple times as well. Like, maybe now this segment was just added again. Let's actually see here in the console the segments. And the last segment between 200, 200 and 100, 300. I think that's this one here. Yeah. And you can see they're exactly the same. Let's try adding a few more segments, even though they are going to be copies of themselves. And now we see here 18 segments, but we can really only count 1, 2, 3, 4, 5, 6. So it doesn't make sense to have more than 6 segments here. We wouldn't be able to see them, and we wouldn't be able to tell that there are duplicates there. This last one actually is the same that we had previously, but in reverse. P1 is P2 and vice versa. We're going to need to handle that case as well. So let's go back here and convert this into a try add segment as well, and move that to the success and have the same kind of structure as here, pretty much. Let's go to the graph and implement this method. Try add segment. And it's going to be very similar to the try add point, but we first check if this contains the segment, and if it doesn't, then we add segment and return true. And here we return false. Like so. This contains segment is going to be here. And what we do is, again, use the find method on the segments this time. I'm going to loop through them using this S and find the one that equals the given segment, like so. We're going to need to implement equals functionality for the segment as well. So here equals is going to be return p1 equals seg.p1 and p2 equals seg.p2. But we also want the opposite check if the points are flipped. So we're going to do or p1 equals seg p2 and p2 equals seg p1. Now, if we refresh and add a few segments, we can see they're false appearing many times. Eventually, one of them will work. Okay, so now we have all 6 of them here. And when we go in the console and type graph segments, they are indeed 6. So it works. But before we move on, this line of code is quite complicated here, checking so many things. And it's always good to try to simplify. 2 segments are the same if they include the same points. So we could make a helper method here called include point and return this p1 equals point or this p2 equals point. So now we have a way to check if the segment includes a point. And 2 segments are equal if this includes p1 and this includes p2. It makes sense. And if you save and refresh, it still works. But it's much nicer to read in this way. And you'll see that later we'll need this includes for other reasons as well. Now, this part here, where we check to see if the indices are different, we could incorporate it part of the try add segment. So try to see if the points are equal, and if they are, it won't add the segment. So we could actually have success here defined as so, and we don't need to use let here. We can use const again. So try add segment now is going to not only check if it doesn't contain the segment, but also if p1 is not equal p2. Let's save, refresh, and try adding segments again. And we still have 6 here. Great. Now let's go to index.html and have a way to remove these segments also. I'm going to copy this and say here remove a segment at random and remove segment like this. And the function for removing is going to be like this. I'm going to first check to see if there are any segments. So if graph segments length is 0, you can also have methods added to the graph that check if it has segments or returns the point count if you want to do a really, really proper job. But this is JavaScript and I don't bother too much. So here I'm going to log no segments, just as a warning that no bother trying to remove something, there's nothing to remove. And return. And otherwise we are here where we get a random index from the segments this time, and remove segment, the one at that index, like so. We also need to copy this code here, otherwise we won't see the change after it happens. And now let's implement this remove segment. I'm going to go here and say remove segment splice. So splice removes elements at the given index. Here we get the index of this segment, and I want to remove just one element, the segment itself. Now you can add many other methods here. Maybe removing the segment by the index. We already had the index here to begin with. Or try to remove a segment similar as those other ones. But they won't be needed in our project, and I'm not going to over-engineer this. Refresh and remove segment. Okay. 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 All good. And if we try one more time, no segments written in the console. Great. Let's remove the points as well. For that, I'm going to add another button here, remove random point, remove point, and let's copy this remove random segment like this, and have here remove random point. If graph points are empty, no points. Index is going to come from the points this time. Remove point, graph points, and let's implement the function remove point in the graph file. Let's copy this remove segment and put it here in the points section and rename it to remove point, the given point, and it's gonna look inside of the points array and splice the points index of point. Would have been faster to just rewrite this, but I wanted to show you how similar these functions are. Now let's save this, refresh, and when we remove a point, we can see it's gone, but I'm removing all the points, and now we also get that message there, but the segments are still there, and that makes no sense. How can you have segments between points if there are no points? So let's make it so that when we remove a point, it also removes all the segments that contain this point. So the new logic will be here. Let's first get some segments with point, the given point, and then for each segment of this small list, we remove the segment like so, using the method that we have defined earlier. So we need to implement this get segments with point, and I'm going to do that here in the segments section. Get segments with point. We start off with an empty array, and now loop through all the segments of this graph. if the segment includes this point, then we add it to this array. And at the end here, we just return the array of segments that contain this point. Simple enough. Let's refresh and remove point, and you can see that the segments connected to it are also gone. Let's try adding some points, adding some random segments. Question for you, given a number of points, how many segments can there be between them? Like in this case, we have 17 points. How many segments can there be here? Let me know in the comments. And now we can also try removing some segments, removing some points. Good, everything seems to work. But one more useful button to have here would be to clear everything, to remove everything. I'm gonna implement the method for that here. It's really easy. Let's say this will be dispose of the graph. And I'm just gonna set the points and the segments to empty. Setting the length attribute like this doesn't generate new objects for them, so it reuses the same array object. And in index.html, let's copy this and say remove all, and the remove all function calls graph dispose, and we need to copy this again if we want to see the update. Refresh, and it works. Now you could build an interface like this. Maybe when adding point, it wouldn't just be a random point, but have there some inputs for the X and the Y. Adding the segment, maybe it can have a drop down for the first point and the second point. Removing, again, a drop down with all the segments and all the points. And that interface would work, but it would have so many clicks and so much use of the keyboard that nobody would use it nowadays. I will teach you how to make a modern interface, so we won't need these buttons here. Let's remove them actually. I will keep the controls section here because we might use it later, but no need for these functions at all. All that was important was to have here all these useful methods inside of the graph class. Next time, I'll teach you how to make a really nice editor for our graph as well. For that, we'll need one key bit of math, how to calculate the distance between 2 points using the Pythagorean theorem. If you don't know how to do that, you're in luck. I have not one, but 2 videos on the topic. This one is more advanced, going into higher dimensions as well. I remember learning the Pythagorean theorem from my math teacher, who announced his retirement earlier this month. I thought now would be a good time to say thank you. So to make this more personal, here's me speaking Romanian. Acest curs e o combinație de programare și matematică. Azi am avut nevoie de coordonate carteziene, data viitoare ne va trebui teorema lui Pitagora și încetul cu încetul importanța matematicii va crește. Vom folosi operații cu vectori, elemente de trigonometrie. Multe dintre acestea le-am auzit prima dată de la dumneavoastră. E foarte posibil ca acest curs să nu existe dacă nu vă întâlneam. Și cred că va fi de folos cuiva. Mai mult, motivul pentru care a început să-mi placă informatica e că puteam să aplic undeva ce știam de la matematică, pe care am învățat-o că m-ați tot încurajat de-a lungul anilor. Așa că, mulțumesc! Multă sănătate și numai bine!